Welcome back, guys. We're about to start Unit 3, and our Unit 3 theme this time will be, why can the same chemical both help me and hurt me? So let's talk. First things first, I want you guys to give this balancing equations exploration a shot. You can find it available on my wiki spaces, or you can check out my digital file cabinet at the SimonTechnologyAcademy.org website. So this is going to be lecture 3.1 on balancing chemical equations. It's pretty difficult, so follow along with me very closely and I'll make sure that you end up being successful. First things first, we're going to be working on how to balance a chemical reaction as listed in Learning Target 3.2, and we're going to discuss the law of conservation of mass and how it relates to chemical reactions, because it's going to explain to us why we need to balance chemical equations. First things first, we need to know, what is the law of conservation of mass? Essentially, what the law of conservation of mass states, that no matter what reaction we run, matter can never be created or destroyed. Whatever we have here in the world today is here and will always be here. We cannot create anything more, we cannot destroy anything. The only thing we can do is change the form these things exist in. And this is a very important concept. But first, let's discuss how are states indicated in chemical reactions. It's a nice little fun video.
We're almost.
So let's give it a, this is 100 tons of TNT. Kaboom. TNT, also known as trinitrotoluene, right here. These three nitro groups attached to the toluene, which is the CH3 and the benzene ring, right there, results in a C7H5N3O6 chemical formula, and that's TNT right there. Now, with this TNT, when you blow it up, you get nitrogen gas, water, carbon monoxide, and carbon residue. Now, this is a chemical reaction in and of its very most basic form. It's a skeletal chemical reaction, but we're going to have to do a lot more than just that. It's not complete yet. When you run a chemical reaction, substances form new substances once they've reacted. And we use chemical equations to show what that reaction looks like. So the TNT results, and it explodes, it combusts. You form new substances that we can actually indicate and show in our chemical reactions. So here we have carbon before and after the reaction. Carbon here, carbon there. Hydrogen, hydrogen here, hydrogen there. Nitrogen, nitrogen here, nitrogen there. And oxygen, oxygen here, and oxygen there. Some chemical symbols to help us with this. Remember that plus signs indicate it separates two or more reactants or products. The arrow indicates that it's going from the reactants to the products, and a reverse and forward arrow indicates it can go back and forth. But we see that we have everything we started with before and after the reaction, indicating that the law of conservation of mass is in some way accurate. When we run a chemical reaction, we have our reactants, which are on the left, and our products on the right. The reactants react to form the products which are produced. It's generally an easy way to remember. Now there's four different forms that these molecules can come in. They can either be solid, as we see right here, liquid, as we see right here, gas, or aqueous. And aqueous just means dissolved in water. If I take an Alka-Seltzer tablet and drop it in a thing of water, it's gonna fizz and eventually disappear. It's not actually gone, it's just now aqueous, which means it's dissolved in water. Perfect. So, let's go ahead and label the reactants and products in this equation below. Well, we remember that reactants are the ones that are reacting. And so we see this arrow right here, and we can split the equation right in half. So this right here, this group right there, is going to be my reactants, because that is what is going to react. And when they react, they are going to form the products. And my products are formed on the right side of the arrow. So over here, I have my products. And all of them, all of my products are always listed, because the law of conservation of mass states that we need all of these again. And here over here we have an aqueous substance, a solid, another solid, and another aqueous substance. Hope that makes sense. Give the next one a try to see if you got it, and we'll be moving right in to balancing chemical equations. And now it's about to get real. One thing you need to know is that when you balance chemical reactions, using the law of conservation of mass, we need to remember that we need the same amount that we started with at the end as well. So the reactants need to equal the products, because whatever we start with can never be created or destroyed. Even in a reaction, the form is going to change, but the actual amount of the substance itself will never really change. So we need to balance chemical equations to make the same amount on the reactant side as in the product side. And it looks like this. We are going to put coefficients in front of our chemicals, in front of our chemical symbols and compounds, to change the number of substances that we use in the chemical reaction. Now, we can never change the subscripts, the ones on the bottom, but we can put numbers in front and multiply the compound itself by a coefficient. This coefficient right here, this 2, indicates that we have 2 sodium molecules, Na, and 2 chlorine molecules. And this is how we're going to balance our chemical reactions. When we do that, we want to organize our thoughts like this. Here we have a table, and in it we can write exactly what element we have in each state, how many are in the reactants, how many in the products, and check it off if it's balanced. For instance, if we have sodium and chlorine, and we have 3 atoms in the reactants, 3 atoms in the products, 2 molecules of chlorine in the reactants, 2 molecules of chlorine in the products, it would be balanced. Now, this is not a great reaction right here since there's only 2 things. So we probably want a hydrogen in there as well. Maybe we have 10 of those. We want to make sure that all of them, the same in the reactants and products, are all balanced. And if you can't think visually about what that looks like, check these out. So here we have a regular chemical equation. We have 1 aluminum atom, 2 bromine atoms, and we make 3 bromine atoms with 1 aluminum atom. The problem is that we only have 2 bromine atoms on the left side, and we have 3 on the right side. So how do we reconcile this situation? Well, we're going to put some coefficients in front of them. We're actually now going to have 2 aluminum atoms, 6 bromine atoms, and have 2 sets of 3 bromines to 1 aluminum. And now we have a very balanced reaction, because there's 6 bromine, 2 aluminum, 2 aluminum. Now we're ready to go. Ready to try the first one? Let's give it a shot. I'm going to balance this chemical reaction right here with hydrogen peroxide, H2O2, decomposing into water and oxygen gas. So first things first, I want to draw my table. I have hydrogen, and I also have oxygen. On the reactant side, I have 2 hydrogens and 2 oxygens. On the product side, I have 2 hydrogens and I have 3 oxygens. 2 plus 1 is 3. So I'm going to need to balance these. So what I'm going to do is I'm going to see which one I need to balance first. Well, first things first, I need the oxygens to be equivalent. So I'm going to multiply this whole set by 2. So now, these 2 hydrogens are being multiplied by 2, which means I have 4 hydrogens. And these 2 oxygens are being multiplied by 2, which means I have 4 oxygens. Now I'm going to have to balance these out, and I think the easiest way to do that is to multiply this water molecule by 2. So I now have 4 hydrogens on the right side. 2 times 2 is 4, and 2 times 1 is 2, plus 2 more is 4 over here as well. And guess what? That is a balanced chemical equation. So I want you to give this one a shot right here. It's a little more complex, as you can tell. We have a sodium molecule, we have silver, nitrogen, oxygen, chromium. We have quite a few different things here. It's really not as hard as it looks. Once you're done with that one, move on to this one right here and try some extra examples. We're going to do a candy balancing reactions activity in class, so please let me know when you're ready. Give your exit slip a shot. That's it for me. Hope this helped.